All right, finally, why would you use algebraic over geometric? So my final attempt at trying to sell you here. So I have a 45 degree, and let's call that vector u. Let's call that vector v, and let's call that determine u given the following vectors. Let's actually change this to vector w. All right, and we'll make this the resultant. So what I've done is I've given you two of the vectors. We're looking for the third one that gives us that particular resultant. Just as an aside, let's talk about adding, subtracting three vectors. The triangle or parallelogram method only works for two vectors. Okay, so geometrically, you would have to, add two vectors. So first step, add two vectors, which would mean you'd have to draw cosine law and then sine law. And that gives you resultant 1. So therefore, resultant 1. Okay, so that doesn't actually give you your final answer if you're adding more than two vectors. So then, step 2 would take resultant 1 plus a third vector, which means that you'd have to draw it again. You'd have to use cosine law again, and then use sine law, and now you have your final resultant. Okay? So you have to do all of that if you want, and that's just three vectors. Just three vectors. So, doing it algebraically. And this particular example is actually more challenging because we are looking at not adding three vectors, we're actually looking at finding the missing resultant. So I'm just going to place this over to the side to point out this is kind of the process you'd have to go through and do this geometrically. So if we're going to do this algebraically, we know a resultant occurs from adding the three vectors together. So u plus v plus w. We're looking for w, so we're trying to isolate for w. So here's where your grade 9 algebra skills come in. You just isolate for w. And anything you used to do in grade 9 through grade 11 still applies here. How do you isolate w? You subtract the u vector and the v vector from both sides. So subtract u, subtract v, which means you would have your resultant minus the u vector minus the v vector equals w. And that's it. So you've done, this is the thinking part, dealing with vectors. Now we move back to our knowledge section. So we take our resultant, we subtract our u vector, we subtract our v vector, and we end up with the w vector. So I've just rewritten it in a stacked notation. So what does my resultant equal? So I got to convert it to algebraic form. So remember your algebraic form, again, for any vector, so I'll just use the general u, is magnitude of u cos theta I plus magnitude of u sine theta j. I said that should be on your cheat sheet. This is what you're going to be using when you convert something to algebraic form. So the magnitude of my resultant, it's given, 15, and my angle is 75 degrees with the horizontal. That's given information. So 15 cos 75 I, and again, for this one, both the x component and y component will be positive. I'm moving right and up. So plus 15 sine 75 j. So there is my r vector. My u vector, it is 25. Its length is 25 cos 45 I. And again, because it's moving to the right and up, you got positive x, positive y. So plus 25 sine 45 j. Finally, my v vector, it is moving to the left, so it'll have a negative x component It's horizontal, so there's no j component. So it will be minus 10I plus 0j. Extend that bar out. So what is my w vector? In brackets, 15 cos 75 minus 25 cos 45 minus 10, oops, sorry, plus 10 because you're subtracting a negative. That's my I, plus 15 sine 75 minus 25 sine 45, and then minus 0. So there we go. So what have we done? We have found our missing vector right here. This is the missing vector, and we've done it in a lot less steps. If you were to do this algebraically, this would take you probably a good 2 or 3 pages to go through in order to make sure you did it correctly, whereas we're all done. All that's left, magnitude of w is equal to the square root of 15 cos 75 minus the 25 cos 45 plus 10 plus 15 sine 75 minus 25 sine 45. And now we have the magnitude defined. So there's the magnitude of w, the angle at which it's located, tan inverse of the 15 sine 75 minus 25 sine 45 divided by our other mess, minus 25 cos 45 plus 10. So there's the magnitude and angle. So therefore, vector w is magnitude of w. Use the right symbol. Oops. Magnitude of w, and again from above. So I've stated it. Add a direction. Of. So now I look at my direction here, and I make a decision. And this is where your estimation skills come in. So 15 cos 75 minus 25 cos 45. I'm going to say that it's probably, I'm going to say it's going to be a positive value because I'm only subtracting one value. And again, it's an estimate. If it's in the end, it'll work out because I'm looking at your process. The other one, 15 sine 75 minus 25, I'm going to say that's going to be a negative value. So my guesstimate in this case will be it was going east, and I rotated theta from above, so it's already been defined south. Okay? And at the end of the day, all I'm looking for is, did you make an estimate as to its sign? Because you don't have a calculator. I understand that. So if this should have been down here, should have been a north instead of a south, you're not going to lose marks because you didn't have a calculator. What I'm interested in is the process itself. So I'm looking at the process. All right. So there you go. Again, if you compare this process I just did versus this one, you're going to find that this is enormously more efficient and a lot quicker. So on the test for this unit, I will make you do one geometrically, and then make you do one algebraically, and then after that question on the test, question 4 or something on the test, then I don't care after that what method you use. You can use geometric all the way through, you can use algebra after that. But there's one question that says do this geometrically, one question says do this algebraically, and then after that, your option, your choice altogether. Homework's listed there at the bottom. If you have any problems, you know where I'm going to be. Good luck.